Okay, obviously you're asking me to graph this function, so right away I will do this for so many reasons. I will not touch the function, I will not do anything. I will get my table going. And of course, my first thought is, every time I'm asked to graph a function, my first thought must be and will be, what? The domain, right?
Yes.
The domain. That's the very first thought. And I know that x cannot be 0. And I know that x cannot be 2. If the function is not defined at 0, its derivatives will not be defined at 0. Only now I will notice something very important. This factor of x minus 2 disappeared. I will immediately write x equals 2 is a hole in the graph. Because the factor goes away, that is not a vertical asymptote. When the factor goes away, it will be a hole in the graph. When the factor stays in the denominator, that will be a vertical asymptote. Guaranteed. So after I simplify, the function becomes y equals x plus 2 divided by x. Very nice. I can also rearrange it. I may need this sometimes and this one, the other one other times. X over x plus 2 over x, which is 1 plus 2 over x. Of course, I want to differentiate this. I don't want to differentiate that. So I'll see what I need when I need it. So first, my first thought is to exhaust the function, meaning x and y intercepts and behavior near left and right, behavior near left and right, and only then I move on to the first derivative. So for now I found the domain, I found the vertical asymptote and the hole in the graph. I know that when I plug in 2, in the simplified form, I prefer this, when I plug in 2, 2 over 2 is 1, 1 plus 1 is 2. So the hole in the graph will be 2 comma 2. When I talk about the vertical asymptote, I know there must be infinities left and right, and I will be using this, not that, because this is a product and it's easier to study the sign. Right? So I will find the limit as x approaches 0 from the left of x plus 2 over x. And I know it's 2 over 0, so I know it has to be infinity. And I plug in negative 0.1, positive over negative. And now in the same way, limit as x approaches 0 from the right, from x plus 2 over x will be infinity, because with 0.1, I have one more step, and the x-intercept. Okay, x-intercept is when y is 0, a fraction is 0 only when the top is 0, which means x equals negative 2. So there is a negative 2, 0 here as the y-intercept. I'm sorry, I meant x-intercept, of course, when y is 0. And now I need to determine the end behavior. So I have to find a limit, x plus 2 over x when x approaches infinity. This is infinity over infinity, L'Hopital's rule, so limit as x approaches infinity. The top is 1, the bottom is 1, 1. So then y equals 1, horizontal asymptote. There is nothing else. We're completely done. We cannot plug in 0, it's undefined. We determine the x-intercept. We determine the end behavior, behavior for the hole, and behavior for the vertical asymptote. Completely done. Now I'm ready to differentiate. Of course I'll differentiate this, not this. So find the first derivative. 1 prime is 1. This will be negative 2 over x squared. I love it. It's always 0. Less than 0 is never 0. A fraction is 0 only when the top is 0. So the function is always decreasing. But I don't know if I made an error anywhere, so let's check. From 1 to 0 to negative infinity, is it decreasing? Yes, it is. From positive infinity to 2, yes. From 2 to 1, yes. I'm ready to study the second derivative to find intervals of concavity. So this is the first derivative, so I'm going to write it like this because it's easier to differentiate. So now the second derivative will be 4x to negative 3, which is 4 over x cubed. But for the purpose of, it's never 0. For the purpose of studying the sign, I will see this. Why? Because this is always positive. Only this will give the sign. So to the right of 0, x is positive. To the left of 0, x is negative. So the function has to look like this, and like this. One thing that does not fit in the chart is the symmetry, but a function with a hole in the graph at 2 and a vertical asymptote at 0 cannot be symmetric, but I have to mention that. I have to say not symmetric because f of negative x will not equal f of x and will also not equal negative f of x. Not even, not odd. At this point, all I need is the table. I don't care for anything else. All the other work is good, but it's not going to help me right now because everything is right there, summarized in there. So page 11. Okay, so when we graph a function with asymptotes, we have to graph the asymptotes first. And this function has 2 asymptotes. 1 at 0, okay, this is an overkill, I really don't need to. But 1 is at 1, so y equals 1. I have a point that is negative 2, 0. I have an open point that is 2, 2. And now I'm ready to graph the function. From approaching 1, crossing at negative 2, 0, and approaching negative infinity, because a function can never cross a vertical asymptote. It can cross a horizontal, it can cross a slant, but it can never cross a vertical asymptote. To the left-hand side of the a vertical asymptote. So here's the graph. On the other side, the function is coming from positive infinity, goes through the hole, you know what I mean, and it approaches 1. And this is function f of x, x squared minus 4 over x squared minus 2x. Can anyone give us the range for this function? So we look at an example with hole in the graph.
Negative infinity to 1 and with 1 to positive infinity.
Careful.
Oh, yeah.
Very good. So negative infinity to 1, perfect. Union 1 to 2, and union 2 to infinity. Very good.
I'm sorry, I have a quick question. It's kind of going back on your graph there. Can you explain the rationalization where you said the left side of 0 is negative infinity and the right side is positive infinity?
We determine the limit. So the function now is simplified to x plus 2 over x. So if you remember in chapter 2, we talked about vertical and horizontal asymptotes. So when I conclude that this is a vertical asymptote, because the function is undefined at 0 and the factor stays, then I have to immediately find the limits left and right of the vertical asymptote. So when I find the limit from the left of 0, I plug in negative 0.1. So negative 0.1, negative 0.1. Negative 0.1 plus 2 will be a positive number, but the denominator is negative. So positive divided by negative will be negative, because I picked a number from the left-hand side of 0. When I pick a number from the right-hand side of 0, like 0.1, the numerator is positive, the denominator is positive, that's why we get positive.
Okay. Thank you very much.
So, thank you. And then when we graph it, it makes sense. Because if by mistake I write positive here, then I know there is an error. Because the function is always decreasing. So from 1 to 0 to positive infinity, something would be terribly wrong. Because here it's decreasing, but then from 0 to infinity will be increasing. So from approaching the horizontal asymptote, it crosses the x-axis at negative 2, 0, and it drops to negative infinity on the left-hand side of the vertical asymptote. And then on the other side. Is that better?
Certainly. Thank you.
Thank you. Very good question. Is this okay? So now, with your permission, I would like to look at a function that has a slant asymptote. So those functions any rational function with degree n in the numerator and degree n minus 1 in the denominator does not have a horizontal asymptote, but a slant asymptote. It may have vertical, sure, but it will not have a horizontal asymptote, but it will have a slant asymptote. Either going from positive to negative infinity or going from negative infinity to positive infinity. Because when you divide these two, degree n divided by degree n minus 1 will give us a line. And that line is the horizontal asymptote and depends on its leading coefficient. Okay, so let's take a look at an example. Let's say I'm making one up. So let's say x squared minus 4 divided by x. Let me make it slightly more difficult. X minus 1. So I'm given this function, and again, the same procedure, everything is the same. I'm asked to graph it. I'm going to fill up the chart. I'm going to study the function to the fullest, everything possible. I'm going to find the derivative, the first derivative, and so on and so forth. It doesn't change sign. There are no max min. There are no critical numbers, of course. And then I will move on to the second derivative and study that. Put everything together and graph it. So obviously the first thing I'm going to do, I'm going to factor the numerator. I'm going to start my table. How do you feel, if anyone would like, you're not going to hurt my feelings, but how do you feel about this table? Does it make any sense to you? Is it something you would be using? And again, you're not going to hurt my feelings, I promise.
How come the f prime is above? It seemed to be logical to have f of x and f of prime, f prime, and f double prime.
Very good question. So very good question. So here is why you can change the order. You don't have to use this order. It's up to you. But here is why I use this order. Because I want the derivative to be above so I can compare. And I want the second derivative to, because when I graph, I look here and I look here. It will, if I reverse these two, the order, and I put the function and the derivative, then these two rows will be slightly more difficult to see. But if you prefer that, please use it. So I put the function in the middle because it's connected to the first derivative, it's connected to the second derivative. I feel that if I put them in that order, f and f prime and f double prime, I feel that somehow the second derivative is not connected to the function. So I prefer the function to be squeezed between the first and the second. I am more than happy if you invent your own table, and if you swap these two and that works better for you, please go ahead. But what I highly recommend and begging you, use any table you like, but please don't use this. It's almost impossible. They are not summarizing the information in any way. They only study the second derivative, concave upward, downward, and all of a sudden they show the graph. So please invent your own, use mine, but have some way of organizing the information in any way you prefer, but not like this. Okay. So our next step, where am I? I'm here. So first I have to identify the domain, and so that's crucial. My first step. So I have 0, it has to be in the table, and 1 is where the function is undefined as well as its derivatives. Any questions so far? Any questions? Okay. So my next step would be to identify the fact that this is a vertical asymptote and find the limits left and right immediately. Once I say this, I have to find the limits. So limit as x approaches 1 from the left, from x plus 2, x minus 2 over x minus 1. 1 from the left is 0.9, positive, negative, negative, so infinity. And limit as x approaches 1 from the right, from x plus 2, x minus 2, x minus 1, 1.1, positive, negative, positive. And that is done. Now I'm going to plug in 0 in the function. 0, 0, negative 4 over negative 1. So I'm going to write, you don't have to, once you put in the table, it's clear for me. So f of 0 is 4. And now I have to solve the equation f of x equals 0. That's why I factor the top to realize that the two solutions will be x equals 2, x equals negative 2. So 2, negative 2. One other item is the limit at negative infinity, the limit at infinity. I'm done with the function. So limit as x approaches infinity from, I'm not going to use this, of course I'm going to use this, x squared minus 4 over x minus 1. Luckily it's infinity over infinity. The numerator will be 2x, the denominator will be 1, so the limit is infinity. I cannot conclude about the other one, I have to repeat, but I know that this step will be the same, and when I apply the limit of 2x, I will get negative infinity. All the other step is the same. Okay, so I am completely finished with the function. Now I will go ahead to the first derivative. Yes, I'm not going to use this, I'm going to use this. So let's take a look. So the first derivative, top prime minus top, times the denominator prime, which is 1, over x minus 1 squared. Don't be tempted. Don't be tempted. So there is nothing I can factor here. So I'm going to distribute 2x squared minus 2x minus x squared plus 4 over x minus 1 squared. So this is x squared minus 2x plus 4 divided by x minus 1 squared. Critical numbers when this is 0 or when this is undefined, but the function is. That's no such thing. This is undefined at 1, but so is the function, so no critical numbers come from undefined. And let's see if critical numbers come from the numerator being 0. Negative b plus or minus b squared minus 4ac over 2a, not real. This expression is always positive. Everything. Positive, positive. Nice. So this function is always increasing. So if that's the case, this is not real. All does not, it has a positive leading coefficient. It's way above the x-axis, it's always positive. So now, moment of truth. So I want to make sure that these two work well together. And that's when I say, oops, if that's the case. From negative infinity to 0, yes. Supported by the sign of the first derivative. From 0 to 4, yes. From 4 to infinity, yes. From negative infinity to 0, yes. From 0 to infinity, yes. Okay. So now I have to look at the second derivative. Horrible. Horrible. Watch me run out of room. Okay. Terrible situation here. The denominator is x minus 1 to the 4th. A lot of work. Well, I'm going to try it and do what I can. So, 2x minus 2 times x minus 1 squared minus x squared minus 2x plus 4 times the denominator prime, 2 times x minus 1. Okay, not as bad as I thought initially. Okay, do not be tempted to simplify anything. I will factor out x minus 1. Because I'm hoping for this. Let's see what is left. A 2x minus 2 that needs to be multiplied by x minus 1. This is out, and I don't want to forget that 2 that messed me up last time. 2 times this, negative 2x squared, plus 4x and minus 8. Okay, don't be tempted again to do anything, so I'll distribute. So, 2x squared minus 2x plus 2 minus 2x squared plus 4x minus 8 over x minus 1 to the 3rd. That's why I tortured you in the previous chapter with, and don't forget to ask questions on Thursday in preparation for the test. Okay, these two go away. Oh, wow. Nice. So negative 6 over x minus 1 to the 3rd. It's never 0. And the sign will be studied in this way. Why? This is always positive. So I'm going back to the table. Negative x plus 1 is positive to the left of 1, or you plug in a number. And it's negative to the right of 1. So it holds water, and it does not. It's not symmetric. It has a vertical asymptote at 1. So I just have to mention, not symmetric. Okay. Better than I thought initially. So now we're ready to graph. Not before we find the slant asymptote. Here's how we find the slant asymptote. Where is my function? We divide x squared minus 4 by x minus 1 using long division. In this situation, I can also use the synthetic division. And you tell me which one you would like to choose. Because the quotient of the division, I'll erase that, is the slant asymptote. Just the quotient. That's why we need to divide.